This is for Project 1, Case A, the Poiseuille flow. So to start, you click Geometry and make sure it's in 2D. Afterwards, you can open up the Design Modeler to get started on making your pipe. Once it opens, set the units to millimeters and get into sketch mode so you can see the axes. And make your rectangular pipe and set its dimensions for this project. The horizontal distance is supposed to be 150 times that of the vertical. So I'm going to set my vertical to 10 millimeters and my horizontal to 1500. And once you have that set up, you can go to concepts and surfaces from sketches and go to box select, select your whole shape, hit apply and generate. Once this is generated, you can return to the project schematic and make sure to update every time you come back here. And then you can come to the mesh and wait for that to open up. Once it's open, you can select your edges and name your shape, the edges on your shape. So this would be the upper wall of the pipe, this the lower wall of the pipe, the inlet, and the outlet. And click the drop down and look for the arrows to make sure you've actually clicked on what you're supposed to. And now you can start, go to sizing. So you can make the shape for what's going to be your mesh. Select the upper and lowers and add them right here. Make sure it says 2 edges and you don't want it to be by default, so you want to change the number of divisions yourself. I'm going to put 1500 and make sure you say to curvature and set the behavior to hard. Once that's set, you can go to generate and then wait for the program to mesh. Once that's done, you can start the second one with the inlet and outlet. Hit apply, make sure you have 2 edges, and then it's the same thing. Change the number of divisions. Set the curvature, capture curvature to no, and behavior to hard, and then generate again. Once that's done, you can go to the mesh tab up here and click face mesh and select your shape, apply. Make sure it says one face, and then generate again. And once that's processed, you'll know you've completed it once you click mesh, and you can zoom into your pipe. And once you zoom in enough, you'll see all your individual sections that you've made. Once you're done with that, you can go back to your project schematic and make sure to update the mesh. And you can open the setup. Once that's loaded, open modules and set the viscous setting to laminar. And you can close that. And then go to materials, since it's a fluid passing through a pipe. Edit air, and I'm going to set my density to 1 and my viscosity to 1e to -5. It's going to be important later, as our Reynolds number has to be less than 2500 for the flow to be considered laminar and not turbulent. And so you can close that and then make sure that you have air as your material. Once you've done that, you can go to your boundary conditions, edit your inlet. For this, I'm going to set my velocity magnitude to 0.015 meters per second, as this, with the values I put in for density and viscosity earlier, should give me a Reynolds number of 2,200, 500. 2,200, 500. 2,250. And then make sure your lower and upper walls are set to stationary with no slip condition. Otherwise, it will add to your flow. And then make sure that the edit outlet is set to prevent reverse flow. Reference values, compute from the inlet, and make sure that these match the values you put earlier. And you can go ahead and initialize. And once that is done, you can calculate. Or you can set your iterations and then calculate. Once that is done, you're done with the setup panel and you can head to results. Once you're at results, make sure you're on the z-axis because that's where our pipe is. And you can start putting your line. So, mid. For this, the midpoint would be at 75 meters. It should increase the cycle size. Add an endpoint line. That, you can open your velocity contour, set symmetry 1, velocity U, number more contour numbers, and then I. And fix the legend to get it out of your way. And you can see the flow come in, the boundary layer, and it eventually stabilizes. And then chart. Add the lines you made earlier. Now, x-axis, you're going to put the velocity on the y, hit apply, and then you'll be able to see that the endpoint and midpoint lines are right on top of each other since the flow has already developed at that point, while at the development line, which is really close to the inlet of the pipe, it is undeveloped. Then you can go to variables to see our max velocity value of 0.22. And that's it. This is the velocity profile, and this is the contour.